So the first game of the June 2007 LSAT starts off as follows. A company employee generates a series of 5-digit product codes in accordance with the following rules. All right, so let's go through the rules one at a time. The first rule tells us the codes use the digits 0, 1, 2, 3, and 4, and no others. All right, so rule number 1 sets forth our digits 0, 1, 2, 3, and 4, and no others. Rule 2 tells us that each digit occurs exactly once in any code. All right, so we have a 5-digit product code. We have 5 digits, each digit showing up exactly once. So what we see here is a game that's going to be 1-to-1. So you notice again, we have 5 product codes, 5 digits, 0, 1, 2, 3, and 4. And we're trying to place each of these digits exactly once in this 5-digit code. The third rule tells us the second digit has a value exactly twice that of the first digit. All right, so if the first digit was X, the second digit would be exactly twice that, which would be 2X. And you should notice that there are only 2 possibilities from rule 3. Because either our first digit is going to be 1, and our second digit would be exactly twice that, which would be 2, or our first digit would be 2, exactly twice that would be 4. Notice it's not possible to have 3 as the first digit because exactly twice 3 is 6, and 6 is not an option. And obviously we can't have 0 show up first because twice 0 is 0, and each digit only appears once. Which brings us to the fourth and final rule here, that the value of the third digit is less than the value of the fifth digit. So basically what that tells me is that we cannot have 4 appear third, and we cannot have 0 appear fifth. But taking that and applying it now to our 2 scenarios that we've established, again, we know from our first option, we've already placed 1 and 2, we have 0, 3, and 4 remaining. Whereas in option 2, we've already placed 2 and 4, we have 0, 1, and 3 remaining. Now, in our first scenario, since we can't have 4 appear third would have to be either 0 or 3. And since we can't have 0 appear fifth, the fifth position would have to be either 3 or 4. And then in option 2, we've already placed 4, but now 3 is the highest digit remaining, so we know 3 can't be third, which means it has to be either 0 or 1, and then the fifth position would be either 1 or 3. And that is the setup for this game. Now that we have this set up, all of our deductions, let's turn our attention to the questions